Okay, so when you get to Google Classroom, just click on the most recent assignment here, and you should see a PDF. So it might be in the top right corner for you, but click on that, and then at the top where it says Open With, you're going to eventually click on Annotate with Kami. I know you don't have that yet, so go to the bottom where it says Connect with More Apps. Type in Kami. Should be the first one. Mine already says connected, but you'll have to connect. So once you connect, then you'll be able to open with Annotate with Kami. Okay, and the cool thing about Kami is that you're able to edit straight on here. Okay, so there's tools on the left here where you can edit straight onto this PDF. So when you open this document, go ahead and turn to page 9 or scroll down to page 9, and it's all about graphing exponential functions. So we've been doing properties of exponents, so now we're going to graph with exponents. Okay, and some background knowledge here. First of all, here's the equation we're going to be using. F of x is equal to a times b raised to the x power. And a couple things I want to tell you. First off, this f of x is the same as y equals. Okay, so f of x equals is the same as y equals. Number two, this a and b will be numbers once we get down to it. So instead of a times b, it will be, for example, 2 times 3 and then raised to the x power. Okay, so this f of x equals is the same as y equals, and this a and b will both be numbers once we get to some examples. Okay, when we come down here, there are some examples of graphs down here, and most of the time we will be using this second graph. Okay, I just wanted to put all 4 on there just so you know that there are multiple types of graphs, but every graph that we are dealing with will be this second graph. Okay, so all of our graphs will look like this, meaning that they'll start off pretty slow and then out of nowhere they'll shoot up through the graph. Okay, and we'll talk more about this. But a vocab word I do want to mention is an asymptote. Okay, and an asymptote is a line that a graph approaches but does not touch. Okay, so what I mean by that, if we look at our graph up here, the second one, it gets really, really close to this x-axis, but it never touches it. Okay, so this x-axis is an asymptote. It will approach this x-axis, but never touch it. Okay, I know it looks like it's touching it, but if we were to zoom in onto this graph, this blue line will get very, very close to the x-axis, but never touch it. Okay, so asymptote is an important word that we will be using. And the cool thing about exponential functions down here, exponential functions have a horizontal asymptote, and it's always at y equals 0. So there will be times where I ask you, what's the asymptote? And if it's an exponential function, you will always say y equals 0. Okay, so every time I ask you for the asymptote of an exponential function, it will be y equals 0. Okay, if we scroll down to example 1, pay attention how I'm using these tools on the left here, because all of the graphs that you will be using and working out on your own, you'll be using these tools on the left. Okay, so it says graph the exponential function and identify the following characteristics. So to graph this, I want you to first start with a table. Okay, and this will be an XY table. So we'll have X over here on the left, Y over here on the right, and we can choose any numbers we want for this X column. I would suggest you choosing 0 and 1, just because 0 and 1 are very easy numbers to work with. So what you're going to end up doing is plugging in 0 for X. So we want to know what's 3 raised to the 0 power. Well, anything raised to the 0 power is just 1. Okay, what about if we plugged in 1 for x? 3 raised to the 1 power. Anything raised to the 1 power is just itself. So 3 raised to the 1 is 3. Okay, so we have this table here, and really these are just points. So we have 0, comma, 1. Okay, so there's a point. And we have 1, comma, 3 as another point. So let's plot those 2 points onto our graph. So to do that, if you go to the drawing tab here and then stroke thickness, go all the way down to 10, and that will give us a thick dot. 0, comma 1, that's in the 0, going up 1, and we have a dot there. Okay, 1, comma 3, that's over 1, up 3, there's our second dot. Okay, you might be tempted to draw a straight line through these, but if we go up back to the top, all of our graphs start off pretty slow here, and then they're going to end up shooting through those 2 dots that we just made. So go to your drawing. We're at 10 right now. Let's go back to 1 here, and we'll start off slow, and then we'll shoot through those 2 dots. Okay, so I don't expect it to be perfect, but I do need arrows on each side. And remember, this line down here is never going to touch the x-axis. It's going to get really close because this is our asymptote, but it will shoot through those 2 dots. Okay, so that's what our exponential graph will look like. A couple characteristics I want to go over: the domain and range of this graph, the x and y intercept, and then finally the asymptote. So the domain and range we have not talked about yet. The domain is how far left and how far right our graph goes. Okay, so if we were to look at our graph, there's an arrow here on the left. If I were to pull this arrow all the way to the left, it would reach negative infinity. This arrow means it's going on forever. So how far left does it go? Negative infinity. Click on this equation tab on the left. Okay, and we'll do parentheses, negative, click on the pi, and that's where we get our infinity sign. Okay, comma, how far right does it go? Well, if I take this arrow and pull it to the right, yes, it'll take a longer time to get to all the way to the right, but eventually this will go to infinity all the way to the right. Okay, so it goes to the left forever. It also goes to the right forever. So comma, another infinity here, close the parentheses. There's your domain. Okay, your range is how far down and how far up your graph goes. So how far down, comma, how far up. Well, it doesn't go below this x-axis here. It's because that's where the asymptote is. It just hovers above this x-axis. So it's always above here, and it goes up forever because of this arrow. So really it never reaches these negative numbers. It's only the positive numbers that the range is. So your range will be y is greater than 0. So the greater than sign is on your keyboard. It's also in this equation tab right down here, so you can choose either of those. The y-intercept, we have talked about the y-intercept in the past. It's wherever it crosses your y-axis, and it crosses right here at 0, 1. So your y-intercept, parentheses, 0, 1. It's a point, and it's always a point, okay, wherever it crosses the y-axis. The x-intercept is where it crosses the x-axis. Well, we talked about the x-axis being an asymptote, so really it never crosses this x-axis. It just hovers right above it. So the x-intercept is non-existent. We can say none, or NA. There is no x-intercept. And your asymptote, what we talked about, if you come back up to the top, your asymptote is always at y equals 0. So our asymptote is y equals 0. Okay, I know this seems like a lot, especially with the vocab, but a lot of these will repeat every single time. Okay, so I'm going to highlight the ones that repeat every time, meaning your domain is always the same. It's always negative infinity to positive infinity. Your range is always the same. Y is greater than 0. Your y-intercept could change. Not saying that it won't be 0, 1, but it won't always be 0, 1. Your x-intercept will always be the same, and your asymptote will always be the same. So I know it seems like a lot, but 4 out of the 5 of these will always be the same. Okay, so let's try example number 2, and this is where we have 2 numbers. So if we scroll back up here, we just have one number raised to the x power. But if we come down to the bottom, we have 2 numbers, 3 times 4 raised to the x power. So let me show you how to do this if you have 2 numbers. We're still going to be making an XY table. X, Y. And again, you can choose any numbers you want here for X, but I suggest that we choose 0 and 1. Okay, so what you're doing is you're plugging this 0 in for X. And let me show you, you do have a calculator on your Chromebook. So if you come down here to this circle in the left corner, type into here TI 84. It should come up as an app. It's on every computer, and you'll see the calculator that we use at school, and you'll be able to type this in. So we're going to be typing in 3 parentheses 4 raised to the 0 power, exactly how we see it. So 3 parentheses 4. Your caret button is right above the divide button. That's how you get into the exponent. 0 equals 3. Okay, so here we have 3. Now let's plug in 1. Okay, same thing, 3 parentheses 4 caret 1 is 12. So when x is 1, y is 12. So there's our 2 points. I do want you to notice before you go to graph these that 12 is pretty big. We can't go by ones and get to 12 without going way off the graph. So let's go by 2s here. Make sure you make your stroke thickness a 10 so that we can make a good dot. 0, 3. So start at 0, 2, go up a little bit more, is 3, because we're going to go by 2s. 1, 12. Go over 1, 2, 4, 6, 8, 10, 12. Okay, so this is not going to be a straight line because it's an exponential. Change your thickness back to 1. We can draw our exponential here. So it's going to start off slow, and then it's going to shoot up through those 2 dots. Okay, I don't expect this to be perfect. Okay, but there's our exponential there. All right, let's talk about our characteristics here. Our domain, we already talked about, was always the same. So go to your equation tab. Okay, and it's always negative infinity, comma, positive infinity. Your range is always the same. It's always the positive numbers. It's always up here with the positive. It's not down here with the negatives. Okay, so your range is y is greater than 0. Okay, your y-intercept could change, and it actually ends up changing because here it's at 3. All right, and it's also up here. I don't know if I can highlight this. No. Okay, it's also up here on your table, 0, 3. Okay, there's your y-intercept. So come down here. parentheses 0, comma 3. Your x-intercept, there never is one, so none. And your asymptote is y is equal to 0. Okay. So there's a couple of examples on how to graph. If we scroll past here, you'll see some problems that you need to work out. So you need to work out pages 11, which is all just those one numbers. 12, still have those one numbers. 13, so this is where you have the two numbers, so make sure you utilize that calculator here. And 14. Okay, I know it seems like a lot, but I think it only ends up being 12 problems, so you should have plenty of time here. When you're finished, come up here to the right where it says save, okay, and download this. Okay, it's going to export it into a PDF, okay, and then it will be down here on your computer. They're probably saved to your drive as well, and then you'll be able to upload it and submit it to me.